It is fair to say that most Americans are aware of electric cars, with brands like Tesla appearing on the news every day and selling hundreds of thousands of vehicles every year. Within the past few years, seeing an electric car has gone from something that you would tell your friends about to just another daily occurrence, thanks to nearly every major car manufacturer producing at least one electric model. Most people recognize that these electric vehicles are good for the environment because they release no carbon dioxide when they are driven. This is what is known as a zero-emissions vehicle. What most people don't realize is that there are other zero-emissions vehicles that are great alternatives to electric vehicles. These include vehicles powered by hydrogen fuel cells, also called FCEVs or fuel cell electric vehicles, and vehicles powered by the combustion of hydrogen, also called HICEs or hydrogen internal combustion engines. Let's compare these three to see which one is best. The electric cars that most are familiar with, also called BEVs or battery electric vehicles, operate by storing electrical energy in large batteries and then using that energy to power electric motors. Or, as Wilberforce, Tabby, et al. Define in the article, Developments of Electric Cars and Fuel Cell Hydrogen Electric Cars, BEVs are designed to use only battery power to power the motor instead of petrol. In comparison, FCEVs are powered by hydrogen stored in a tank like a traditional gas-powered car. As Charlie Fletcher puts it in Hydrogen versus Electric Cars, Comparing Innovative Sustainability, FCEVs convert the hydrogen into electricity in the fuel cells. This means that FCEVs are essentially the same as BEVs, except for the fact that they produce their own electricity by converting hydrogen into electrical power instead of just storing straight electricity. Finally, HICEs are powered by the combustion of liquid hydrogen or hydrogen in a gas form. In the article, Hydrogen Combustion, Explained, Airbus, a major producer of commercial aircraft, explains that, in the case of hydrogen combustion, liquid or gaseous hydrogen is burned in a modified gas turbine engine to generate thrust. This process is identical to traditional internal combustion, except hydrogen replaces its fossil fuel counterpart. It is important to note that, in this quote, Airbus is talking about hydrogen combustion in the context of powering jet turbines, but the process is the same for automobile engines. This means that HICEs are essentially identical to your everyday gas-powered cars but just use a different fuel. Now let's compare the three to each other. The first advantage that BEVs have over the other three is that they are the most popular. Charlie Fletcher agrees in his article, Hydrogen versus Electric Cars, Comparing Innovative Sustainability, saying that, because the vast majority of zero-carbon vehicles are battery-powered EVs, a robust infrastructure is being developed to meet the rapidly growing demand for EV charging stations. The popularity of BEVs means that there is more infrastructure, such as charging stations, that has already been built. This also lends itself to a reduced sense of uncertainty, as those who drive BEVs don't have to worry as much about finding a place to recharge as people who drive FCEVs and HICEs do about finding a hydrogen refueling station. This also means that it is easier to sell BEVs to people, as the reduced fear of running out of power makes them more attractive to customers. Another benefit of BEVs is how efficient they are. Fletcher describes this in the same article when he says that, most battery-powered electric cars and other vehicles boast around 80% efficiency. This means that for every 100 watts of energy produced, nearly 80 watts will be used to power the vehicle. This efficiency is important as it means that very little energy is wasted in powering a BEV. This means that less energy would be used to power a population of electric vehicles overall, leading to lower costs. Possibly the most important advantage to both FCEVs and HICEs is that they are both refueled like traditional gas-powered cars. This is explained in the video, Why Hydrogen Cars Will Be Tesla's Biggest Threat, where Business Insider states, fuel cell vehicles don't require charging at all. The hydrogen tank is refueled at a hydrogen station in less than 5 minutes, just like your typical gas station today. While this describes the process for fuel cell vehicles, The refueling process is exactly the same for hydrogen combustion vehicles. This is a benefit because it allows drivers to spend less time waiting for refueling, which allows for drivers to get to their destinations quicker. This encourages people to drive, which helps to boost the economy. Another advantage of FCEVs and HICEs is explained in the article Electric versus Hydrogen: The Pros and Cons of Greener Transportation, where Robin Farren writes, critics of hydrogen cars often point to the lack of pump infrastructure available. There are only around 50 public refueling stations in the US, but existing gas stations and pipelines could be adapted and used. The fact that existing pipelines and gas stations could be converted to serve hydrogen vehicles is a massive advantage. This would save incredible amounts of money and time. With BEVs, existing pipelines could not be used and gas stations would have to be converted to electric only. By using existing pipelines and gas stations, infrastructure could be converted to serve hydrogen vehicles much faster and cheaper, which would allow the entire transportation sector to become carbon neutral in much less time. Now let's look at the disadvantages of all three. One of the disadvantages of BEVs is explained in the article Electric Cars and Batteries: How Will the World Produce Enough?, where author Davide Castelvecchi says, anticipating a world dominated by electric vehicles, materials scientists are working on two big challenges. One is how to cut down on the metals in batteries that are scarce, expensive, or problematic because their mining carries harsh environmental and social costs. This is definitely a disadvantage as it defeats the initial purpose of BEVs. If the mining and production required to produce BEVs offsets any environmental gain produced by the reduction in the burning of fossil fuels, then the transition to BEVs is pointless. Another disadvantage of BEVs can be found in where they get their electrical energy from. In his article, Hydrogen versus Electric Cars: Comparing Innovative Sustainability, Charlie Fletcher introduces this problem by stating that the lifetime carbon footprint of a standard battery-powered EV will depend very much on how the energy supply is sourced. This is a very important issue, as a BEV can only be as clean as where its energy is sourced from. If its electrical energy is sourced mainly from coal power or the burning of natural gas, then any environmental benefit is offset. This means that if BEVs replace gas-powered cars, we will also have to find a new, green, way of producing energy for them. The final disadvantage of BEVs is the amount of time that it takes to recharge them. This would make driving more of a hassle, which would cause people to go out less, negatively affecting the economy. Like BEVs, the source of the hydrogen used to power FCEVs and HICEs determines whether or not they are actually carbon neutral. Charlie Fletcher elaborates on this in his article, Hydrogen versus Electric Cars: Comparing Innovative Sustainability, when he explains. For example, in so-called gray hydrogen, the gas is produced through a process known as steam reforming. Steam reforming requires the use of fossil fuels, particularly natural gas, which can therefore significantly increase the overall amount of carbon emissions produced in fueling the vehicle. On the other hand, green hydrogen refers to hydrogen that is produced through the use of renewable energy through a process known as electrolysis. During electrolysis, water molecules, which contain both hydrogen and oxygen, are split and the hydrogen atoms are captured and used to feed the FCEV's fuel cells. Just like with BEVs, if the source of the fuel is not clean, then the cars are not either. Another disadvantage of FCEVs and HICEs is that due to the fact that BEVs are currently the most popular type of zero-emission vehicle, there are very few hydrogen refueling stations. In his article, Electric versus Hydrogen: The Pros and Cons of Greener Transportation, Robin Farren states, critics of hydrogen cars often point to the lack of pump infrastructure available. There are only around 50 public refueling stations in the US. With fewer refueling stations available at this current time, these hydrogen vehicles will be a hard sell to consumers. While the fact that existing gas lines and stations can be converted, the lack of stations is a short-term disadvantage. One final disadvantage that FCEVs and HICEs share is that there is uncertainty over how the hydrogen should be stored on board the vehicle. As D.K. Ross writes in Hydrogen Storage, the major technological barrier to the development of hydrogen fuel cell cars, 4 different methods of hydrogen storage are currently being considered, namely liquid hydrogen, high-pressure hydrogen, solid-state hydride storage, including chemical hydrides, and porous solid adsorption of molecular hydrogen. The first 2 methods have reached the engineering prototype stage, while for the last 2 methods, there is still much to be done in selecting the optimum system for further development. Obviously, uncertainty over such an important part of these vehicles is not good, as it will prevent a standardized method from being commonly sold until a solution is found. In comparison to the other 2 types, HICEs have a disadvantage that is unique to them. Robin Farren describes this in Electric versus Hydrogen: The Pros and Cons of Greener Transportation by stating, critics of the hydrogen vehicle strategy also point to the fact that hydrogen combustion engines can produce the greenhouse gas NOx if not properly regulated. While regulation can prevent this from happening, it is still important to recognize that this can happen, which is a negative mark against HICEs. If HICEs are emitting greenhouse gases, then they are no better than gas-powered cars. Considering the advantages and disadvantages of each of these 3, the best one of these 3 is the FCEVs. This might seem surprising, as it has more drawbacks than BEVs do. This is mainly because less time and money has been devoted to developing FCEVs as with BEVs. There was a time when BEVs faced similar issues with a lack of charging stations and concern over how energy will be stored. It is not unreasonable to think that, given more time and resources, these problems will be ironed out just like they have been for BEVs. With these problems ironed out, the quick refueling times outweigh the efficiency of BEVs, making FCEVs the better option overall. They are as clean as BEVs, without the drawback of long charging times, making them the car of the future.